So on the second part of the notes, we'll be talking about the sum and difference of cubes using these formulas, which are on the front part of the notes. If you don't know what they are, you can go to the front part of the notes or part 1 and we show what those formulas are. These are right from the notes right here. So, first thing you have to do is we have to identify an A and we have to identify B. So I'm going to show you how to do this. So you have to make sure everything is on one side of your equation. So I'm going to add the 27 to both sides. And that gives me 8x to the third plus 27 equals 0. So you have some form of something plus something else. Now your goal is to then write it to the third power. So basically you want to write it so if you put it to the third power it would become what it is. So we're going to rewrite it as something to the third power plus something to the third power. So what number can we put to the third power which would give us 8? What times what is 8? What three of the same numbers? 2. And x cubed, if I put x here, that would work out, right? So basically the goal is to get it into something, if you put this to the third power, you get back to your original answer. Everybody see that? Okay. Now for this one, 27, what times what is 27? 3. So 3 to the third power is 27, so you got to rewrite it like this. And when you get that, the first one is your A, and the second one is your B. Okay? So now, you're going to use the formula. So this is a plus 1. See this one right here, the first one. This is the sum of cubes. So we're going to use this formula. So the sum of cubes says we need A plus B, which is our first factor. So A plus B is 2x plus 3, A plus B, that's from this formula, A plus B, times A squared. What's A squared in this case? What's 2x to the second power? 4x squared. Minus A times B. What's A times B? 6x. Plus B squared. What's B squared? 9. So I just used this formula up here, and now I identified A and B, and that's how you factor it. And this whole thing would be equal to 0. And now from here, we have to factor this one, this side, because obviously this side isn't factored. Now, this doesn't actually factor, and it's hard to do with completing the square because it's got this A term. So what do we do when something all else fails and we can't factor? We got to use the quadratic formula. So this part over here, this factors pretty easily. Okay, I can subtract 3 on both sides, and I get 2x equals negative 3, divide, and this is one of my zeros. Okay. Now over here, I can't do all of that, so I have to use the quadratic formula. So what is my A value in this? My B value? And my C value? Good. So the quadratic formula is x is equal to negative b, so my b becomes positive, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Then you just simplify this. So this becomes x equals 6 plus or minus 36 plus whatever 36 times 4 is, 16 times 9. 144 all over 8. So this becomes x equals 6 plus or minus square root of 180 over 8. Now we need to see if we can simplify the square root of 180. Oops. So we're going to go off to the side and simplify this square root over here. Okay. So the square root of 180, well, I can break that up into 36 and 5. So this simplifies to x equals 6 plus 6 radical 5 over 8. Then from here, we can factor out a 6 in the numerator, right? And then we can reduce this fraction. So 6/8 reduces to 3/4, right? So my two answers are x equals 3 times 1 plus square root of 5 over 3, or over 4, and x equals 3 times 1 minus the square root of 5 over 4. And then, of course, our answer that we had earlier, one of our x's, and then the other two you just find using quadratic formula, simplify the square root. So basically, when you can't factor, you use quadratic formula. We're just putting that into your original processes. So I'll zoom out so you can see this as the whole thing here. That's the whole procedure. We solved using quadratic formula because it was the only way we had to do so. And that's how we did it. Any questions on this part? Okay. So basically, when all else fails, use quadratic formula to factor a trinomial. So let's go ahead and try the next one. So everything's on one side of the equation. So I need to identify what's A and what's B. So this one's going to become A and this one's going to become B. But we have to write this as something to the third power plus something to the third power equals 0. So what can I put to the third power that would make x cubed? X. And what can I put to the third power that would make 64? What times what is 64? 4. 4 times 4 times 4 is 64. Very good. So once we've identified that, our A value is x and our B value is 4. So we're going to plug into this formula up here. A plus B, so x plus 4, times A squared, x squared, minus A times B, minus 4x, plus B squared, plus 16, equals 0. Well, I'm thinking of factors of 16 that add up to -4, and I don't think there are any. No, nothing works. So we could use the quadratic formula like we did over here on the left, but this one might be a good candidate for completing the square. So I'm going to complete the square on this one, but you could very well use quadratic formula and you get the same answer. So it's up to you. So to complete the square, I'm going to leave space before and after my 16, like that. Now I'm going to take half of this term and square it. So what's half of -4? Good. -2 to the second power is? +4. If I add 4 over here, how do I have to balance that back out? Subtract 4. These get grouped together. We're going to factor this section, and I'm going to combine these two. So this becomes x plus 4 times, what can x squared minus 4x plus 4 factor into? What two binomials? Factors of +4 that add up to -4? Good, -2 and -2. Then we combine what is in the green. What does that combine to? What's 16 minus 4? 12. Like this. How can we rewrite something, two identical binomials? Yes. So this would be x plus 4 times x minus 2 squared plus 12 equals 0. So that's where we're at. And then we can use the zero product property. We can set each of these equal to 0. So this becomes x plus 4 equals 0. And this becomes x minus 2 squared plus 12 equals 0. And then I'm just going to solve for x for each of these. So I subtract 4 on both sides, which gives me x equals negative 4. And over here I subtract 12 on both sides, which gives me x minus 2 squared is equal to negative 12. I have to take the square root of both sides, which gives me x minus 2 is equal to, when I take the square root of a negative, what letter do I use? I. So this becomes plus or minus I, or sorry, you should write it like this, not that. Well, that's fine. And then what is the square root of 12 simplified to? My pen's not working. What does the square root of 12 simplify to? 2 radical 3. So this becomes x minus 2 equals plus or minus 2i radical 3. I add 2 to both sides, and this becomes x equals 2 plus or minus 2i radical 3, which means that I have two solutions. I have x equals 2 plus 2i radical 3, and then I have x equals 2 minus 2i radical 3. And your imaginary zeros are always going to be the same but different signs. So in that case, we have a trinomial, or not a trinomial, we have a cubic polynomial with one real zero, and how many imaginary zeros? 2. And doesn't that add up to 3, right? 3 zeros, just like we wanted. So that's how you do it. It's just a lot of algebra. So that's really all it is. And like I said, if you don't like completing the square, you can use quadratic formula. You get the same answer. Alright. So we're going to do 2 more like this, and then we're going to go into square roots, which are pretty easy. So this one over here is a little bit tricky. I first have to find a GCF. So what's the GCF in this case? 3. I'm going to factor out a 3. And then from here, I now have the difference of cubes. So I'm looking at the difference of cubes formula, which is on the front of your worksheet, the bottom formula right here. I'll write it on the top. The formula says if we can write some value to the third power minus some other value to the third power is equal to a minus b times a squared plus ab plus b squared, like that. So I'm going to try to do that with our case here. It just has a 3 on the outside. That's the only difference. So I can rewrite x to the third as x to the third power like that, minus 2 to the third power, because 2 times 2 times 2 is 8. And now I can fill everything in. What's my a value here in this case? It's this value here, x. And that means my b value is 2. So now I'm just plugging into the formula. This is 3 times a minus b times a squared plus b times a, which is 2x, plus b squared, which is 4, like that. Equals 0. Now this actually might be factorable. No, I don't think it is. Factors of 4 that add up to 2. I got nothing. So we're going to have to use completing the square here to factor this. So this is 3 times x minus 2, x squared plus 2x plus 4. I leave space for my new term. What's half of 2? 1. What's 1 squared?
1.
Good. If I add 1, I have to also subtract it. Good. I'm going to factor this section right here. This becomes 3 times x minus 2, x plus 1 squared, because I'm going to get 2 of those factors, plus 3 equals 0. So these are grouped together. And then I can set each of these equal to 0. So 3 equals 0. I got x minus 2 equals 0. And I have x plus 1 squared plus 3 equals 0. And I'm going to try solving each of these. What happens to the first instance? 3 equals 0. Can I solve that? No? Yes? What do you guys think? Can I do something with that? No, I reject it. Over here, I'm going to add 2 to both sides. This becomes x equals 2. I subtract 3 on both sides. This becomes x plus 1 squared equals negative 3. I take the square root of both sides. That becomes x plus 1 equals plus or minus I radical 3. I subtract 1 on both sides, which becomes x equals negative 1 plus or minus I root 3. Which means I have 2 solutions here, which are x equals negative 1 plus I radical 3. And my other one is x equals negative 1 minus I radical 3. So that's that procedure and how you do it. Algebra 2 has very long problems. There's really no way around that. That's just the nature of going into higher math classes. So that's what you get. You got to use completing the square or quadratic formula. So, what kind of zeros do we have? How many real zeros? How many imaginary? Good. So how many total zeros? Which means that our answer should be, or our original is a cubic, 3rd degree. So let's try the last one. This one's probably going to be a little easier, I think. I'll go through this one a little quicker. What's the GCF on this? 2. Factor out of 2. Good. Now we have to find our A and B terms. So we always rewrite this as x to the 3rd and then minus 1 to the 3rd, because 1 to the 3rd power is still 1, so it doesn't change it. Now my A value is x and my B value is 1. So this becomes 2 times A minus B times A squared x squared plus A times B, which is just x, plus B squared, which is 1, equals 0. We don't need that extra parenthesis here. I didn't know if we would or not. It's just 2. Now I can try to factor this. What are some factors of 1 that add up to 1? Anything? No, unfortunately not. So you have to complete the square. So this becomes 2 times x minus 1 x squared plus 1x plus 1, leave space like that. What's half of 1? 1/2. What's 1/2 squared? 1/4. If I add 1/4, I have to subtract 1/4. You square the numerator and denominator. This factors into x plus 1/2 squared. Always half of whatever this is. It factors into 2 binomials of that. And then 1 minus a fourth is plus 3/4. These are grouped together. Equals 0. I set each of these zeros products equal to 0, 2 equals 0. I've got x minus 1 equals 0. And then I have x plus 1/2 squared plus 3/4 equals 0. I solve each of these. This one can't solve. Good. Add, I get x equals 1. Over here I subtract 3/4 on both sides. This gives me x plus 1/2 squared equals negative 3/4. I take the square root of both sides. That gives me x plus 1/2 equals plus or minus I radical 3/2. Everybody see how I got that? Because you can't simplify the numerator, but you can take the square root of the denominator, which is 2. I subtract 1/2 on both sides, which gives me my final answers of x equals negative 1/2 plus I radical 3/2. You can put the whole thing over 2 as well. That would be sufficient. X equals negative 1/2 minus I radical 3/2. And these are our 3 zeros. 2 real, or 1 real, 2 imaginary. So it's really just a lot of algebra that you have to know how to do for these problems. So you guys take a second and get those down. No. So in this example, my graph never touches the x-axis because these are my 2 zeros. So I subtracted 4 from both sides and take the square root of both sides. This one's pretty easy. So we'll do the next one. So in this case, I'm going to add 4 to both sides. And that gives me 25x squared is equal to 4. We are going to take the square root of both sides, which is going to leave me with 5x equals plus or minus 2. Divide both sides by 5, and I get my 2 zeros, x equals 2/5 and x equals negative 2/5, and that would be my 2 answers. So square root ones are a lot easier. Now, what's the difference between example 6 and example 7, their graphs? Which one touches the x-axis, which one doesn't? What do you guys think? Good. 7 touches the axis and 6 does not. How did you know that? 6 has imaginary solutions. Yep, 6 has imaginary solutions. So if you get imaginary solutions as your solutions, you're not going to have a point where you hit the x-axis if you only have imaginary solutions. So if you put these into Desmos, for example, desmos.com, you can always check your work on these. Not a bad idea sometimes. And that's all I have for you today. You guys are going to have about 20 minutes to work on your assignment. Yeah. Mm-hmm.